Hi, my name is Eckhard Ulmer. Let's explore what's new in UHD 4.9. In UHD 4.9, we made it simpler to integrate RF NOC-based USRPs into heterogeneous systems. So let's consider this example architecture where two USRPs, shown in green on the right, interface with a central NI FPGA coprocessor, shown in blue in the middle. The host application is written in LabVIEW and runs on a Windows-based controller, and that is shown on the left. In UHD 4.9, we added documentation and an example how to control an RF NOC-based USRP from LabVIEW using Python nodes. We also added 100 gigabits per second Aurora support for use with the USRP X400 series. And Aurora essentially enables you to stream high-rate IQ data from or to another FPGA target that also supports Aurora. And finally, you can check out those links to learn more. We've also been enhancing one of the core FPGA signal processing functionalities, and that's the RF NOC FFT. We can now process much larger FFT sizes, so all the way up to a 64K FFT. The FFT block can now be configured to act as an OFDM modulator, and that's an essential signal processing block in almost all modern wireless communication systems. Also, we now support multi-sample per cycle processing, which means that the FFT block can now cope with high sample rates, such as the 500 megasamples per second on a USRP X410. So how could I, as a user, take advantage of these capabilities? So let's have a look into a 5G wireless communications example. So far, a software-defined base station would use a USRP as a digital to RF converter and implement all the lower physical layer functionality in software. And this really can limit the supported bandwidth. In UHD 4.9, OFDM processing can now be offloaded to the USRP FPGA, and that reduces in return the computational burden for the rest of the system. I'd like to highlight a few more updates in UHD 4.9. So firstly, we added support for our most recent USRP, the B206 Mini, and our latest RF daughter board, the OBX. Then we improved our documentation to make it much simpler for users to get started. For those who design custom FPGA IP, we introduced a new tool, the so-called YAML creation wizard, and that wizard helps users to create NOC block YAML files in an interactive fashion instead of doing that all manually. Also, we started to deliver DNI-provided NOC blocks as out-of-tree modules, with Aurora being the first example. And those creating own NOC blocks, they could use that as a reference. As always, have a look at our release notes for additional updates.